Hey, sixth graders, as promised, reviewing chapters 10 and 11 on what is science and the tools of science. So let's get started with our vocab. I'm not going to read all the definitions, but I'll just read the word and give you time to look at them. If you need to pause to read them more, go right ahead. So we have science, observing, quantitative observation, qualitative observation, inferring, predicting, classifying, making models, evaluating, scientific investigation, skepticism, personal bias, cultural bias, experimental bias, so 3 different types of bias, ethics, objective, subjective, deductive reasoning, inductive reasoning, scientific inquiry, hypothesis, variables, independent variable and dependent variable, controlled experiment, data, scientific theory, scientific law, the metric system, the international system of units, mass, weight, volume, density, estimate, accuracy, precision, significant figures, percent error, mean, median, mode, and range, anomalous data, graph, linear graph, nonlinear graph, model, system, input, process, output, feedback, safety symbols, and field. So quite a bit of vocab from these 2 chapters. From lesson 1, our key point, lesson 1 of chapter 10, the skills of science include observing, inferring, predicting, classifying, evaluating, making models, and conducting scientific investigations. From lesson 2, scientific thinking involves characteristics such as curiosity, creativity, open-mindedness, skepticism, awareness of bias, honesty, and ethics. Scientific reasoning requires a logical way of thinking based on gathering and evaluating evidence. Scientific knowledge is based on an ever-growing collection of facts about the natural world, but it changes with new evidence or new interpretations. Lesson 3 of chapter 10, scientific inquiry, refers to the diverse ways in which scientists study the natural world and propose explanations based on the evidence they gather. An experiment must follow sound scientific principles for its results to be valid. A scientific theory is a well-tested and widely accepted explanation of observations in experimental results. Scientific laws describe observed patterns in nature without trying to explain those patterns. Then lesson 1 of chapter 11 was the measurements. So a standard measurement system is important because it allows scientists to compare data and communicate with each other about their results. So a meter, abbreviated M, is the basic SI unit for measuring length. Basic unit for measuring mass is the kilogram, or kg. Measuring volume is the cubic meter, so meters cubed. Density is kilograms per cubic meter, so kg/m cubed. The Kelvin scale is the basis for SI temperature units, and the Kelvin, K, capital K, is the SI unit for temperature. The second, abbreviated S, is the SI unit to measure time. From lesson 2, some math skills used in science when working with data include estimation, accuracy and precision, and significant figures. Some math tools used in science include calculator percent error, finding the mean, median, mode, and range, and checking the reasonableness of data. Lesson 3, graphs can display categorical and numerical data. Bar graphs and circle graphs are suitable for displaying categorical data, and line graphs and bar graphs are appropriate for displaying numerical data. So bar graphs use vertical or horizontal bars to display data for separate categories, most often used when you want to show the amount of something in each category. Circle graphs display data in a number of separate categories, only used when you have data for all the categories in your survey or experiment. And these are sometimes called a pie chart. And finally, line graphs are among the most common types of graphs used in science. They display data that show how one variable changes in response to another variable. Lesson 4, scientists use models to understand things that they cannot observe directly. A system is a large group of parts that work together to perform a function or produce a result. Scientists often use models of systems to understand how systems work. So we have mechanical systems, such as heating and air conditioning systems, elevators, and engines. And then environmental systems, biological, geological, and physical parts. And finally, lesson 5 from chapter 11. Good preparation helps you stay safe when doing science investigations in a laboratory or in the field. And when any accident occurs, no matter how minor, tell your teacher or another adult immediately. Then listen to their directions and carry them out quickly. So that's it for your review. Please complete the modal questions for chapters 10 to 11 test. If you have any questions or need to review something, please do so. Ask me the questions if you have them. Otherwise, get the test done and have a great day.